All right, so this is chapter 8, section 3. It's called Trigonometry. We call it Trig for short. Our learning objective is to use the sine, cosine, and tangent ratios. We studied ratios at the beginning of this chapter to determine side lengths and angle measures in right triangles. All right, so trigonometric ratios. When you have a right triangle, the sine of angle A is the ratio between the leg opposite of A, which in here is little a, and the hypotenuse, which is C, little c. So the sine of angle A is the ratio between A and the hypotenuse C. The cosine of angle A is the length of the leg adjacent to angle A, which the one right next to angle A is B over the hypotenuse, which is C. So the answer to this is B. The tangent is the leg opposite of angle A, which is little a, and the leg adjacent to angle A, which is little b. So it's A over B. These ratios, memorize these. I don't hardly ever tell you to memorize anything. Have the trigonometric ratios memorized. It'll make your life a ton easier. So for this works even when we're not talking about angle A. I can talk about angle B and still make these ratios work. So angle B, the sine of angle B is going to be the opposite side, which is little b, over the hypotenuse, C. So I'm going to draw a line from sine of B to B over C. The cosine of B is the adjacent side A over the hypotenuse C. Adjacent side A over hypotenuse C. So I'm going to draw a line from B to A over C. And then the tangent is opposite over adjacent, B over A. So your lines should look like this. So suppose triangle ABC is a right isosceles triangle. What would the tangent of angle B equal to? Explain. So if I have equal sides, so if this side were, let's say that this was 2, and this was also, it's isosceles, so this is also 2. So both A and B are 2. If I'm finding the tangent of angle B, it would be 2 over 2, which is equal to the whole number 1. So the tangent of an isosceles triangle would be equal to 1. Alright, so we're going to look at this problem, writing trigonometric ratios. Our question says, what are the sine, cosine, and tangent ratios for angle G? We are going to highlight our angle, and I would recommend doing this for all your problems. So we are looking at angle G because everything is related to that angle. So the leg opposite of angle G is 15, and I'm going to put a little OPP, yeah, you know me, right by 15. All right, so, and then let's circle the hypotenuse so we know where the hype is. It's always the longest side. And then adjacent is the one that runs right into it that is not the hypotenuse. Adjacent, I think of it as your next door neighbor. All right, so write each trigonometric ratio. So if I'm looking at the opposite, I got 15. If I'm looking at the hypotenuse, I got 17. Boom. That is all you do. You might have to simplify it. You might not. All you're doing when you are finding the sine, cosine, and tangent is writing a fraction. That's it. So the adjacent is 8, and that's over the hypotenuse, which is 17. And then the tangent is opposite 15 over adjacent 8. apply that knowledge. Find the value of W, that's right here, to the nearest tenth. We're going to use the value 54 degrees as our angle of focus. So we're focusing on 54. So if we're focusing on 15, let's label, so 15 is like our angle A. So we're going to label our sides. W is opposite, and so yes, I'm down with OPP. And 17, is that the adjacent or the hypotenuse? Hypotenuse, because he's across from the 90 degrees. So we got a hypotenuse and an opposite. We go back and we look at which ratio goes with hypotenuse and opposite, and we are looking at sine. So we are looking at sine is the trigonometric ratio that uses the sides W and 17. So the error that this student made here was that they used cosine. So let's find the correct value, and I wanted to go over this with you because sometimes calculators are a little bit funky in how they want you to input. So what I want you to do, if you are at home at your leisure, I want you to try this on your own calculator. Make sure you're getting out the right number, because if not, then we need to figure out. Definitely being able to use your calculator to find these ratios is important. So for this computer calculator, I have to actually put in the sign first, but hold on real quick. I actually need to calculate this. So if the sine of 54 degrees is equal to W over 17, I'm solving for W. I need to multiply both sides by 17. So in fact, 17 times the sine of 54 degrees is equal to my value W. So I'm going to put this in my calculator. My recommendation is you always do your trig first, because all this is a decimal. It's a fraction. So you go, in my computer calculator, you go put the 54 in first, apply the sign, which is right here, and I get 0.8090. Then I'm going to multiply it by 17. And I get 13.75. It says round to the nearest tenth, so that would be 13.8. All right, so if we look at problem number 3, use the figure below. What is the measure of angle Y? So I'm going to highlight angle Y. He is my angle of focus. And number 20 says circle the angles that, or circle the lengths that you know. We know that the side opposite of angle Y is 100, and we know that the side adjacent to angle Y is 41. So when we're looking at sine, cosine, tangent, the tangent is the one we want to use. So if you know sine, cosine, tangent ratio of an angle, you can use the inverse sine to find the measure of the angle. So we're going to out to here. So we are going to use tangent of Y to write our ratio. And tangent is opposite over hypotenuse. The opposite, or opposite over adjacent. The opposite side is 100. Then we're going to use the inverse. So tangent, this little to the -1 means inverse. of 100 over 41. And let me show you on a calculator how that works out. Please, we are in degrees here, so you want to make sure your setting on your calculator is degrees. We're going to put this ratio into our calculator, so 100 divided by 41. I hit the equal sign so I can make sure I don't accidentally only take the tangent of the top or only the tangent of the inverse tangent of the bottom. So on this calculator, I'm going to click the inverse button. And you can see it makes this sine inverse, but we want tangent inverse. So now I just click it. So I've inputted the ratio, inverse, tangent, 67.7 degrees. It has asked us to round to the nearest degree, and that's 68. On a regular scientific calculator, you'll have a shift button or a mode button. Sometimes you'll have to press the shift button and then the tangent to get inverse to go.